Hello, my name is Nicholas Stewart, and this is my demo video for Experiment 8. For this experiment, I'm going to be using chip 7476IC, chip 7404IC, a breadboard, a 5-volt power supply, switches, and LEDs. So the first thing that I need to do is make sure that my breadboard is properly wired to power and to ground. So first I'm going to wire my breadboard to ground. So I place my wire in there and twist it shut, and then connect this to ground. Next, I'm going to connect my breadboard to power. 5 volts of power. After that, I'm going to connect my power of the top of my breadboard to the power of the bottom of my breadboard, so that both of these bars are going to be powered. And then I'm going to connect the ground of the top of my breadboard to the ground of the bottom of my breadboard, so that those are connected as well. Okay, now I'm going to use chip 7476 IC, because that's the one that has my JK flip-flop inside of it. It has 2 JK flip-flops inside of it. Here's my chip 7476. I make sure that the half circle is on my left, and I'm going to place it onto the center of the breadboard. Next, I'm going to make sure that I have power running to my chip and also ground running to my chip. So let me look and see in the lab manual where my power and ground are supposed to go. Okay, so ground is supposed to go to number 13. That's 16, 14, 12, 16, 15, sorry, 16, 15, 14, 13. And that's going to connect to ground. Next, I'm going to connect my chip to power. VCC is pin number 5. So I have 8, 7, 6, 5. Okay. Now let's look at the instructions to see what we need to do next. It says connect J and K inputs of the flip-flop shown in figure 8.1 to data switch 1 and data switch 2 respectively. So, let's connect J and K to switches 1 and 2 respectively. One J is chip number 4. Sorry, pin number 4. Said chip number 4. 1, 2, 3, 4. Oh, I need a much longer wire. 1, 2, 3, 4. There we go. To switch number 1, J goes to switch number 1. And then K is pin number 16. That's this pin farthest to the left on top. Pin number 16 is going to be wired to switch number 2. And switch number 2 is right here. There we go. Next, it says make sure that the preset and clear inputs of the flip-flop are connected to VCC. So, preset and clear, preset 1 and clear 1, because there are 2 flip-flop chips in here. I mean, there are 2 flip-flops in here, but I'm using flip-flop 1, so I need to find clear 1 and preset 1. Preset 1 is pin number 2, so I have to connect pin number 2 to VCC. Pin number 2 is going to be connected to power. Next, I need to connect pin number 3, which is the clear input. Pin number 3 needs to be connected to power also. If we look at our book, for asynchronous JK inputs, when pre and clear are both high, they will have no effect on the JK flip-flop. It can then respond to J, K, and the clock. So we are freeing this flip-flop up to only respond to J and K and the clock. Next, I connect logic switch A to the clock input of the flip-flop. So I need another long wire, and I'm going to connect switch A to the clock. And the clock, whoa, one moment. The clock of flip-flop 1 is pin number 1. So I'm going to connect that to pin number 1. There we go. Next, I need to complete the truth table on truth table 8.1 to verify that the flip-flop is operating properly. So let's look at this. I filled in some answers, but these answers are wrong. I'm going to correct the answers as I show this to you. So, turn on the power. Then after that, make sure that J and K are both low. J is switch 1 and K is switch 2, and they're both low. I'm going to toggle my clock a couple times just to make sure that I'm getting the correct result. And, oh, I forgot the most important part. I have to connect my Q output. My output Q needs to be connected. Pin number 15 needs to be connected to an LED. So I'm going to connect pin number 15 to LED 0. Now, next, I'm going to toggle the clock again. And as we can see, LED 0 is low. It's not lit. So we can actually leave this one the same. Next, we're going to bring K to high. I'm going to switch K to high and leave J low. Then I'm going to toggle my clock. Okay, so as we can see, when J is low and K is high, the output is low. And that is the same as in our book for a JK flip-flop. For a clocked JK, since this applies now, because our preset and clear have been both set to high, it operates like a normal clock JK flip-flop. So J and K, when K is high and J is low, the output for Q is low. Next situation is when J is high and K is low. J is high and K is low. When J is high and K is low, let me toggle my clock. Okay, I did a few things to change my circuit around. First of all, I just flipped my wires around so that the ground is connected to this one and the power is connected to this one, so that I don't have to do the weird twisting thing over here. Also, I moved my VCC to actually VCC because before it was connected to ground for some reason. So let's do this whole thing again. It's just trial and error. And this is a bit of a complex lab. Okay. So, I need to turn my power on. And when when J and K are both 0, and I toggle my clock, nothing happens. The light stays unlit, the light stays unlit. That's low. When J is low and K is high, and I toggle the clock, it still stays low. So I can leave this as low. When J is high and K is low, and I toggle the clock, one sec. Okay, so found out what the problem was. It was that my ground was not attached correctly. So I fixed that problem. Now, let's look and see what needs to happen next. Okay, so when J and K are low, it says there's no change in Q. So, let me just go to the next one. When J is low and K is high. When J is low and K is when J is low and K is high, we're supposed to get a low. So, when J is low and K is high, it's supposed to be low, and it is low in all cases. Okay, so that's doing what it's supposed to. When J is low and K is high, when J is high and K is low, let's look and see what's supposed to happen. When J is high and K is low, it's supposed to be high. The LED is supposed to be lit. So, when J is high and K is low, let's toggle the timer. The clock, toggle the clock, and it's high. There we go. Alright, so I can make this high. And when both of them are high, in the case that both of them are high, Q toggles. So let's try that. And as you can see, it toggles on and off. But for some reason, when I had them both low, there we go. Now it's doing what it's supposed to. When they're both low, it doesn't toggle. It just stays off. When they're both up, it toggles on and off. If it's on here, and I switch it to low, it stays lit because there's no change. So this is working properly. Okay. Thank goodness that's working properly. Okay, let's look and see what needs to happen next. Next, I have to remove data switch 2. Let me turn the power off. Remove data switch 2 and connect data switch 1 to the J input and the input of the inverter. So we're going to need an inverter for this. That's chip 7404. Sorry, 7404. I'm going to place that on the breadboard next to chip 7476. Okay, so I disconnect switch 2. And then I connect data switch 1 to the J input, and the J input is number 4. So I connect data switch 1 to the J input. Data switch 1 is currently connected to the J input already. And then next I need to connect the input of the inverter to the J input also. So here is the J input, and here is the input of the inverter. Next, I connect the output of the inverter The output of the inverter is going to be connected to input K. And input K is, if I'm not mistaken, pin number 16. Yes, input K is pin number 16. So I'm going to connect pin number 16 to the output of the inverter. Now I can complete table 8.2. Let me turn on the power. And let's see here. This is a J flip-flop, right? Well, anyway. Okay, so when I have J at 0, and I toggle the clock, it stays at 0, so I can put that as 0. Let's hope that's correct. And then after that, I have J being 1, so J is high. And then I toggle the clock again. And it lights up. It alternates when I toggle. I'll just put that as a 1, I guess. Okay. That's it for the first part. Next, I'm going to connect the circuit that is shown in figure 8.3. Oh, wait a second, I need to answer this question. The circuit behaves as an asynchronous input JK flip-flop. I'm not sure if that's correct, but it at least sounds good. Okay, so part 2. JK flip-flop in toggle mode. Connect the circuit shown in figure 8.3. So figure 8.3 is over here. I need to disconnect my circuit as I have it right now so that I can do figure 8.3. Let me do that quickly. Okay, so I have disconnected all of the rest of that circuit except for chip 7476, its ground, and its power. Next, I need to construct figure 8.3. So figure 8.3 is going to use 2 JK flip-flops instead of just 1 JK flip-flop. That's fine because the chip contains 2 flip-flops. So first I need to connect Q1 to clock 2. Q1 is 15. Clock 2 is 6. 8, 7, 6. There it is. Next, I need to connect Q to an LED, Q1 to an LED. So, Q1 is again number 15, right? Yeah, Q1 is 15. So I connect 15. Sorry. Dang. Some of these don't go in very easily. Okay. There we go. 15 is going to be connected to an LED. I'm going to connect it to LED 0. Next, I need to connect Q2 to an LED. So Q2 is 11, pin 11. So let's see, 9, 10, 11. It's going to be connected to an LED. LED 1. There we go. Next, I think that's it for the setup. So let's look at the instructions. Connect all J and K inputs to VCC. So I need to find J1 and J2. Sorry, J1 and K1. And connect them to VCC. J1 is 4. 1, 2, 3, 4. Connect that to VCC. K1 is 16. So I'm going to connect 16. Pin 16. It's going to be connected to VCC. Next, J2 is 9. So 9 is going to be connected to VCC, to power. And next, K2 is 12. 9, 10, 11, 12 is going to be connected to power as well. Okay, so that's our J's and our K's. Our J's and our K's are connected to power. Next, it says connect the pre-inputs of each flip-flop to switch 1. In order to do this, I'm going to have to create a column that is devoted to switch 1. So I will connect switch 1 to column number 20 here. And I will connect switch 2 to column number 21. I just have to remember which is which. So I need to connect each clear input to, each pre-input to switch number 1. Let's find out where the pre-inputs are. Pre-input number 1 is, or preset number 1 is pin number 2. So I need to connect pin number 2 is going to be connected to column 20. That's switch number 1. And clear number preset number 2 is 7. So 7 is going to also be connected to column 20. There we go. And next, clear number 1 is going to be connected to switch number 2. Clear number 1 is pin number 3. So pin number 3, 1, 2, 3, is going to be connected to switch, column number 21. Which is switch number 2, and clear number 2 is pin number 8, and that is also going to be connected to switch number 2, which is column number 21. There we go. So we've done that. All of our pre's and our clears are connected to their appropriate switches. Next, I set both switches to high. Oh, another thing. Let's see, the clock is... It never says to connect anything to the clock input. Oh, yeah, it does. Connect the clock input to switch A on the breadboard. So the clock input is just going to be the input of my first clock. My first clock input, oh, you can see that right here. The first clock input is my clock input. So my first clock input is actually pin number 1. So pin number 1 is going to be connected to switch A right here. There we go. Next, toggle A 5 times and observe the state of the LEDs. Let me turn the power on. With both switches set to high, switch 1 and switch 2 both set to high, and I toggle the clock 5 times. Let's see what happens. 1, 2, 3, 4, 5. Each time I toggle the clock, a different number appears in binary. 1, that's 3. 2, that's 0. 3, that's 0 again. 4, that's 1. 5, that's 1 again. 6, that's 2. 7, that's 2 again. 8, that's 3. 9, that's 3 again. 10, that's 0. 11, that's 0 again. 12, that's 1. 13, that's 1 again. 14, that's 2. 2 again. 3, 3 again. 0. So it's counting up to 3 in binary. So let's go to the chart, and let me turn the power off to reset this. Well, anyway. It starts at let me start this where I started, which was at 0. There we go. So it starts at 0. Then it should go to 1. Then it should stay at 1. Then it goes to 2. There we go. See? Interesting pattern, right? So Q is equal to 0 independent of our Q output. Wait a second. That's a different question. Next, I have to remove the connection from switch A and connect it to switch 3. Let me turn the power off. To remove the connection for switch A and connect it to switch 3. Toggle switch 3 5 times and see what happens. 1. Oh, wait a second. 1. That's 3. 2. That's 0. 3. That's 1. 4. That's 3. 5. That's 3 again. So it's still counting different numbers. Let me just keep clicking. 1. 1. 1. 1. 0. 1. 0. 0. 1. 0. 1. 0. 2. 0. No, sorry, that's 1. 1. 1. 1. 1. 0. 0. 0. 0. 1. 1. 2. 1. 2. 2. This time it's kind of random. 3. Showed 3 for a second. It's really quite random. So I said that compared to switch A, switch 3 takes longer to affect change on the LEDs. Because you saw how many times I was switching it before it would finally change. And then also, it said toggle the clear input to flip-flop B, flip-flop below, sorry, the flip-flop B. Toggle the clear input of the flip-flop B low. So, flip-flop B, the clear input, is currently connected. The clear input is currently connected to 8. 8 is connected to switch number 2. So, switch number 2 needs to go down. Right? Because it needs to be flipped low. So what will happen to the output of flip-flop B? Well, let's find out what will happen to the output of flip-flop B. Well, it says on our chart that if the clear input is flipped to low, while the pre-input is flipped to high, Q will equal 0, independently of J, K, and the clock. So as you can see, the LED is off, and if I flip this switch, nothing's happening. The LEDs are still off. And if I switch these, oh, what's going on? That's not supposed to happen. Okay, forget that. Okay, just forget that. Okay, let's just move on, because I spent like 5 hours troubleshooting this. Okay. I have to figure out why that happened. Why is it important to use a demount switch like switch A as the clock input? The answer is to ensure that there is a clean transition between levels. You don't want any, like, half levels. In figure 8.3, the J and K inputs are known as control inputs. In figure 8.3, the pre and clear inputs are known as asynchronous inputs. And in figure 8.3, the flip-flop's outputs will respond to the J and K input level only at the toggle of the clock. And that is the end of experiment 8. Thank you for watching.